Okay, so put that aside, do that quietly. Well, because I'm starting and I'm actually recording today's session. You can do that quietly without talking to anybody, but just don't talk to anybody, okay? We're going to start today's session. It is recording live on YouTube. Rachel's not here. I got to turn this off myself. See, our phones should not be on ring. Let's everyone turn their phones to silent, just like my phone was trying to do that. So let me just, everyone turn your phone ringer off, media off. Okay, everyone do that. So we're recording it, and so for whenever we don't have everyone here, we're going to be recording. So what we're going to do first today is we're going to go over the math section. I graded them, and it wasn't by machine, I did it by hand, but that gave me a more direct look at what people are missing. There were actually some questions here that every person missed in math, and I saw some trends here. Our numbers that we got here were not as high as I thought. I thought this class was acing math when we did practices, so I do want to go over these together. So let's keep the reactions down and let's talk about them. Let me just get a show of hands. Who wants to talk about question number 1 on page 80? Question number, let me see a show of hands on that. Question 4. So I'm looking for stuff where there's a little higher number of people. We'll come back. Question number 5. How many hands on this one? Huh? Yes. I'm not asking for who got it right, because otherwise I wouldn't review it. So question number 5. So 3 people. Let's go over this one here. It says the fences of a number cube, the faces are not fences. The faces of a number cube are numbered 1 through 6. The cube is rolled twice with the probability that both rolls land on 3. Who wants to explain how you get this one? Let's go with Brian first.
There's a 1 in 6 chance that it lands on 3 the first time, and a 1 in 6 chance that it lands on 3 the second time.
That is correct. When you're doing 2 rolls of the dice, they are called independent events, okay? Independent events means that the first event does not affect the second event. Does everyone understand what I'm saying? When you roll that dice the first time and you roll that die the second time, they don't affect each other. Because they're independent, you multiply. So the answer here is 1 out of 36. On the note of probability, when do you add probabilities? Does anybody know this one? A lot of people got this one wrong because they added 1 6 and 1 6. Maxwell, you have it right there on number 5. Number 5. When do you add probabilities together? I'm going to show you. This was rolling a die twice. If I said, what is the probability of getting a 4? We know it's 1 out of 6. What is the probability of not getting a 4? It's 5 out of 6 because there are 5 other numbers. This one, you add up to 6 out of 6. The difference here is this is rolling a 4. This is not 4. The other numbers besides 4 are 1, 2, 3, 5, and 6. So there's 5 outcomes that are possible. This is when you add because you're getting all outcomes over all outcomes. This is rolling a 4. This is not rolling a 4. This is roll 3 the first time, roll 3 the second time. And the reason why you multiply these two is that the first time and the second time do not affect each other. These are affected because there's only a 1 out of 6 chance when you roll that you'll get a 4. But there's a 5 out of 6 chance that you will not get a 4. So this is added, okay? Questions on that? How many of you guys have seen this in school? Not seen it? Some people have, some people haven't. How is it possible? You guys go to the same school that you saw it and you didn't?
I came at 5th grade.
Okay, that's possible. Okay. I was just wondering, because I figured you guys were classmates. But okay, so we go from number 5. How about number 6? Who wants to review number 6? This is 2 hands there. This one here, I'm just going to go into it real quickly. Number 6 talks about, they give you this equation here, and we know the rules of PEMDAS, right? Everyone knows PEMDAS, right? What's the first thing we got to do with PEMDAS? Summer?
Parentheses.
Parentheses. Do we have parentheses here? We do. So our equation says 2 times the quantity x plus 3 is equal to, not equal to, minus 5 is equal to 8. Okay? So since we have parentheses, what's the first thing we can do here?
Distribute.
Correct. So Maxwell says distribute. When you have a number multiplied by parentheses, you're going to distribute. So you get yourself 2x plus 6 minus 5 equals 8. We're following PEMDAS. We finished parentheses. There's no exponents to deal with. What's the next thing we can do here? Summer? Do we have multiplication to do? Not right now. This 2 and this x are already multiplied, so there's nothing else to solve on that. What can we do next? Yes? 6 minus 5 equals? 1. So you have 2x plus 1 equals 8. What's the next thing you do here? Deborah?
Subtracting one.
You're subtracting on both sides. And your final answer here is 3.5 because you're dividing, right? Yes, Summer?
Wouldn't it kind of be easier just to plug in all the numbers and see like which one works?
You could, but since 3.5 turns out to be the answer, if you did it up here, it would have been a little bit less friendly, right? Because you would have had decimals and junk like that. What we're doing here is we're just following PEMDAS, but up to a degree. This is one thing I want to emphasize here, and I know none of the math books at school mention this, but when we get to, this is just in parentheses here, at this point, this is a starting point where you are actually doing isolating of a variable, because we're trying to find x. When you isolate a variable, the method actually becomes SADMAP. I know that sounds weird, but if you look at what we did here, we did subtraction here, we did subtraction here, then we did division. We're actually going in backwards order. So when you start isolating, this was just kind of simplifying up here. This up here was just simplify because we wanted to clean up this parentheses. But once you get to this point where you have everything lined up, you're really just going SADMAP on that. I don't know if any teachers at school have mentioned that, but that's really what you're doing. Okay. Questions? Okay, let's move forward. Number 7, I think most people got this one, but did anybody need to talk about this? Who knows the definition of prime? That's probably the only thing I'm going to... Yeah, Nico, what is prime?
No other number goes into that number but itself.
The better way to say it is a prime number is divisible only by itself and 1. So a prime number is divisible only by 2 numbers, itself and 1. That's how I would say. Okay. Hopefully that's easier to remember that way. Okay. Let's continue. Let me just double check something. So number 8. How many people want to talk about number 8? Number 8? All right. Number 9? Whoa, resounding. You know why? I think everyone missed number 9. Across the board on this. I should have seen all hands. Some people are like, I'm too cool to raise my hands, so I'm not going to raise my hand, right? But let's look at number 9 for a second. This is a tricky question here. And let me have, Maxwell, you want to read that for us, number 9?
Ellen lives 12 miles from work. On Monday morning, she drove to work in 15 minutes. Coming home, it took her 30 minutes. What was her average speed on Monday?
So I saw a lot of people's writing on this, and I noticed how people were doing it. Well, they give us 12 miles to work. So you have a distance to work and you have a distance from work. So you have, let's call it distance 1 to work, distance 2 back to work. They're the same. Does everyone agree on that? Distance to and from work. It tells us that she drove to work in 15 minutes. So time 1 and time 2, it tells you also coming home 30 minutes. Now the question asks, what's the average speed? So I'm going to write S2 and S1. One of the mistakes that many students make is that they assume that the average speed is simply S1 plus S2 divided by 2. Does anybody know why it is not S1 plus S2 divided by 2? Yes, Alexandra.
Okay,
It is not.
no, because you're trying to take like the average of the two speeds. You're multiplying
Do you know?
first by this.
Stick with my question. My question is this. I'm going to write it here. I'm going to write this. Does anybody know why S1 plus S2 divided by 2 does not equal average speed? Yes, Brian?
Since 30 minutes is 2 times the amount.
Yes. The reason is because the duration matters. What Brian said is one of the trips is 30 minutes, the other trip is 15. I'm going to give you a really extreme example. If you travel on a bicycle and you're going 10 miles an hour on your bicycle, and you want to average the speed of riding on a bicycle versus flying on a plane, an airplane travels at a much faster speed. Let's say you rode that bicycle for 10 hours, okay? But on that airplane, you only flew 1 hour. The difference is that plane might be flying 700 miles per hour, but only for 1 hour. So it is affected by duration if you were to average the two things, okay? So now let's go back. So I'm going to show you what the formula is in a second. This was the trick to the question, is knowing that S1 plus S2 is not the average, okay? I cannot emphasize that. So if we do this, the speed that they mentioned here, everything here was distance in miles, and this is minutes here. So this is 12 miles in 15 minutes. What's a better way of looking at 15 minutes in terms of an hour? Does anyone, because the final answers are all dealing with hours. So what's another way of looking at 15 minutes? Yes, Brian? Right. So this is saying 1/4 of an hour. Okay. This one then is just going to be a half hour. Does everyone see that? So in terms of distance, this is 12 miles that Helene travels in a half hour. So what's her speed? Brian?
24 miles.
Right, it's 24 miles per hour. Okay, and then her speed when she was going to work was how much then? Yes, Brian?
48 miles.
Yes, because you multiply by first. So this is 48 miles per hour. The reason why I'm doing this is because I'm going to show you the difference between S1, S2 divided by 2 and the real formula. Question, Nico?
Wait, how did you find what's more important?
Because if this is half an hour that she traveled 12 miles, if she traveled 1 full hour, she would travel 24 miles. So that's 24 miles per hour. If in 1/4 of an hour she travels 12, multiply this by 4, it would be 48 miles per hour if it was a full hour, okay?
What did you multiply 15 by 4?
No, you don't. You multiply the distance. This is in 15 minutes. So if 15 times 4, you get 1 full hour. If you said this is done in 15 minutes, she's traveling 48 miles per hour. It's faster. But here's the big but. This is what I've been trying to get to because I emphasize why that formula doesn't work. The real formula for average speed. I'm just showing you this because I showed you the last thing for a reason. I'm going to show you this because this is the more important. Average speed is D1 plus D2 divided by T1 plus T2, okay? So I'm gonna put in the numbers. The distances were 12 and 12. So this is 12 plus 12. The times were 15 minutes and 30 minutes, but let's put them into these fractions here, 1/4 plus 1/2. So this is, so we know this is 24 miles divided by 1/4 plus 1/2. You're gonna have to have a common denominator. This is gonna be 2/4, so this is gonna be 3/4. So when you have a number divided by a fraction, what do? We what? Multiply, I heard something else. I was like,
I just said reciprocal.
oh, I just heard something weird. I was like, what? Okay, so it's 24 times 4/3. So this is 8 times 4 equals 32. Okay, the answer is 32 miles per hour. This is miles per hour. But just for the sake of it, I want to show you guys that S1 plus S2 divided by 2 doesn't work. So S1 was 48, S2 is 24. I'm just going to do it up here. That would be 72 divided by 2 equals 36. So when we did S1, S2, it gave us 36 miles per hour. Some of us use that as our answer and probably were wondering, why did Eli mark this wrong? I thought I knew this. The reason is because duration affects the actual distance and time, so, and the speed. So the real answer is 32. But do you guys see, this is your magic formula. This is not your formula. Does everyone see that? Average speed is D1 plus D2 divided by T1 plus T2. It is not the other formula. I'm not going to say it because I want you guys to forget it. That's what. Okay. I'm glad we went over that because I know that every single person missed that question. So, okay, it's not hard, and I know this is stuff you guys have learned. So this is stuff that you can add to your memory. Should we talk about number 10 here? Number 10. Okay, a couple of hands. Number 10, 3 hands. Number 10. All right, let's talk about it. I see a few hands here. This is talking about point -32. You probably had to draw a grid there or draw a coordinate, XY coordinate plane. Okay, so they're asking about -32. 1, 2, 3, 1, 2. And that point is called P. Okay. They also mention here that P apostrophe, whatever you want to call that, is the image of P reflected across the y-axis. This is your y-axis. If it's reflected across, you're looking this way. Okay. So since it's reflected across, you're looking at 1, 2, 3, and right here, this is P apostrophe. So it's the key to answering this question is to identify where is it reflected. Some people mistake it for reflecting this way. That's the x-axis. That's not what they're asking. They're saying reflected across the y. So your value here is 3, 2. Okay, so that's your answer on that one. Number 11, a lot of people miss this one. How many people want to go over number 11 here? So it's the majority here. Okay, let's talk about this one here. This is actually a classic question here of an inscribed type of circle here. So I want to talk about this for a second. It says about what % of the square is shaded. So in order to find this out, you're really trying to find the area of a circle here. And they didn't give us any values as to the radius of this. So the best move is to pick a number. So I'm going to just draw this thing for a second here. So my drawing, of course, is not a perfect circle, but the way that you do this is, since they're looking for the percentage of it, I would choose friendly numbers here for your radius. What's a friendly number for this one?
1,
1?
2. I don't know.
I would just use I would use an even number here. I was going to go a little bit bigger just because the way that they drew this thing, it's kind of like two halves here. So 1, if let's just go with 4 and 4 for this. So this radius will be 2 and 2, right? That makes it friendly. So our area of our circle, what's the formula for area of a circle?
R squared.
Pi r squared. Yeah. So area of a circle equals pi r squared. So our area in this case is going to be 4 pi. And then what's the area of our square in this case? Right, it's length width, which is equal to 16. Now, the reason why I did this is I wanted numbers that were a little bit friendlier to deal with. So you're subtracting basically, or not subtracting, sorry, you're doing percentage here. So the percentage shaded is equal to area of the circle divided by area of the square, right? So that's going to be pretty friendly here. This is 4, and this is 4 pi over 16. These are friendly numbers to reduce, right? So this is actually just pi over 4. And if you think about this, this is 3.14 divided by 4. So you could do the division here, and you're going to have to actually physically divide this to find the answer here.
Really?
Well, how are you going to
Test. That's what they would make you do?
Well, I mean, it's going to be more than 75%. And the problem is A, B, and C are all greater than 75%. So, the hard part is not really the division. It's just setting it up and knowing what you're dividing, which is area of the circle divided by area of the square, right? Because you can see all this stuff now, it seems kind of obvious, right? But if I didn't lead you through it, it might have been a little bit less obvious originally, okay?
How much do you go into pi? Like 3 by 5?
Don't go farther than 2 decimals. I know pi goes infinitely, but you don't want to do that, right? So just do 3.14 divided by 4, you get 785. That's the answer on this one. Okay, so 0.785, that gives you A, because you wouldn't want to go beyond that since all the answers are just 3 digits, right? They're only going 1 decimal past the whole number. So best answer there is A. Okay, questions on that? Makes more sense now, right? Let's talk about number 12 for a second here. Did anybody want 12? Show of hands. Don't worry if anybody else, just raise your hand. This is for you, okay? Don't feel like if no one else is doing it, I'm not going to do it, okay? This class is for you, so don't worry about anybody else. So let's talk about this. This is 1/3 plus 1/6 equals 1/2. They're looking for just 1/2 on this, right? And you're looking for 1/3 plus 1/6 equals 1/2. The answer on this one, I think, you're looking, well, because of this, you're looking at how they're divided in here. And let's see, what's the best way to look at this? 1/3 and 1/6. 1, 2. I forgot what I gave you guys as the answer on this one here, but they're kind of like looking at 2 different shapes here. So if you look at these, obviously F and G are both halves, but they don't have any correlation to, they don't have the correlation to 1/3, to, let's see how I do this one. This is a little tricky. What do we have the answer on this, Deborah? This is G. This would be, well, it is 1/2. And I guess you have, well, I'm not sure what the 1/3 and the 1/6, how I would play that. This is out of 6, but I'm not sure how they use 1/6 on that and 1/3. 1/3 is obviously one of the 3 shaded or one of the unshaded. 1/6 would be, I guess if you were to add that together, common denominator could be 6. So that would be 2, well, let's see, you could do 2 over 2. 2 over 2 plus that would be 3/6. That's what I would do on that one. That's probably the only way you could get that. And I guess that's half, but they don't put it in 6. So G is probably your best answer on that. The other ones are dealing with 8s on F. H and J are not 50%, so you can't really use those two. That's kind of an interpretation of their drawings on that. Did you have a question, Nico?
No.
Okay, all right. 13, 14. 14, 15, 2 hands there. 15, this is talking about a label here. If the label weight is accurate to the nearest 1/10 of an ounce, what is the smallest amount of time that you would expect to find in this jar? To the nearest 1/10 of an ounce. So this is, it says average, it says the weight is 2.2, and it says the smallest amount of time to the 1/10 of an ounce. So if it's off by a 1/10, it could be up or down by 1/10. And let's see, is accurate to the nearest 1/10 of it. Well, okay, 1/10 of an ounce would be, let's see, because this is 2 ounces, 1/10 of an ounce. This is kind of strange here. This is like, what is the smallest amount of time? Well, obviously you would go with 2.15 on this because 2.25 is greater. So they're looking for less than 2.2. So I'd go 2.15. Is that what the answer was on that? Yeah, because it's less than. The average weight would be 2.2. So you're just kind of looking at that. That was observational more than it is calculating. 16 on this one. 17. 17. 1, 2, 3. Okay, let's talk about 17. Weight of a newborn baby is 8 pounds, 2 ounces. When he was weighed by a pediatrician on his first visit, then he weighed 8 pounds and 15 ounces. By what percent has his weight increased? What I would do here is use the total amount. I think some of us might have just subtracted the 15 and the 2. Let's see what you do. Percentage increase comes from this formula here. So what you want to do here is this. So your new weight is 8 pounds and 5 ounces. Your old weight is 8 pounds 2. So when you do this, obviously you subtract these two. The difference is 3 ounces here. How many ounces go into a pound? 16. So 16 plus 2 is 18. So the change here is 1/6. That's a 16.6% change. That should be the answer. What percent? They don't use that. Let's see what happened here. 8 pounds, 2, that's 3. 16 plus 2 is 18.
You can multiply by 8.
Multiplied by 8. What percent?
8 pounds.
Oh, shoot, that's right. So this is 1/6. You mean multiplied by 8, though.
They're 8 pounds, 2 ounces.
8 pounds, 2 ounces, right? What percent did 16 plus 2? It's 18 ounces. That's
So you have to multiply 16 by 8 first, and then you add 2.
16 ounce. Oh, what am I thinking? That was just 1 pound. I was blanking out. I know what you're saying now. I was blanking out. Right. So 16 times 8 is 108. No, is that right? 16.
128.
128 plus 2. So this is 130. That's better. That's why I wasn't working. I was like, that doesn't sound right. The difference here is 3 out of 130. So let's see what you do here. So you'd have to divide this here. Yes, right?
After the middle step, it's 8 pounds and 15 ounces.
Oh, shoot, that was my mistake there. I was writing too fast. Oh, it's 15. Sorry, that made a big difference. This one, I was like, that doesn't look right. So 15 was 13. So this is 110. So this answer is 10%. That's 10% on that. Okay, well, it helps when I write the right numbers on there as opposed to the wrong numbers. But the answer, so new minus old divided by old times 100%. That's a 10% increase on that. Okay. Let's go to the next part with the comprehensive test, and we'll start with number 1 on that one. How many people want to talk about number 1 here? Number 1. This is on page 86. 1, 2, 3. Okay. The answer here is the square root of 100 because the square root of 100 is 10. So that is a whole number. All of the other ones, when you take the square root of them, you're going to have numbers still in the radical. And so, or you're going to have decimals. That just won't happen. So let me just erase this. Any questions on that one as to why 10 is your best answer? Whole number means no decimals, no fractions. I'm just going to use as an example square root of 50 here. This is going to be 25 times 2. This is 5 root 2. 2, if you guys know it, the square root of 2 is going to be a decimal. Okay, so that's not going to be your answer there. Same thing happens with C and D because they all leave behind the square root of 5. And square root of 10, you can't really pull anything out of it anyways. So number 2, number 3, number 4. Couple of hands. Let's talk about 4 for a second. It says that a pitcher won 20 games in each of his first 3 seasons and 24 games in his 4th season. What is the mean? I'm just going to show you the setup on this, but this is pretty straightforward. It's 20, 20, 20, 24 divided by 4 because it's 4 seasons, right? And that's how you find the average on that one. Okay, mean is the same as average. Let's talk about number 5, 6. Couple hands on 6. So this one here, I think a lot of people were not familiar with the rules of these figures, but it says all sides are congruent here. It's not an isosceles triangle, which is only 2 sides that are congruent. It's not a rectangle because the rule of rectangle is the opposite sides are congruent. The pentagon doesn't have to have all 5 sides congruent, but a rhombus does. A rhombus looks kind of like a parallelogram, but the difference between parallelogram and a rhombus is that all 4 of the sides are equal on a rhombus, whereas on a parallelogram, only the opposites are equal. Yes, a rhombus is a parallelogram, but a parallelogram is not necessarily a rhombus. So, yes.
I didn't make this clear. What's congruent mean again?
Congruent means equal length. Similar does not mean equal length. Does everyone know the distinction between similar? So I could have 2 figures of different sizes that are similar in terms of their angles, might have the same angles here. So they'll be similar if all the angles are similar to each other. So the opposite angles might be similar. However, the lengths are not congruent to each other. Congruent means that the lengths are equal to each other. Okay. How about number 7? Did we get this one? How many hands want to talk about 7 here? Just one? Okay. Number 8, 9, 10, 9, no, just 2, 10, 1, 11, Okay, let's go to the next page. This was kind of interesting. Number 12 here, geometric patterns. Number 12. Couple hands here. So it's more than half. Okay. What do we notice here between figures 1 through 4? Anybody notice anything just on first glance of it?
The intervals between each number of dots add by 1 each time.
What do you mean by the intervals add by 1?
1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 is 10,
Okay.
10 plus 5.
Let me just write this one in here. All right. Yes, this was 1, this is 3, this is 6, and this one was 10. So he said the intervals, say again what you had there, Maxwell? Intervals.
The intervals between each number of dots increase by 1 each time.
Increase by 1. Why do you say increase by 1, though?
1 plus 2 is 3.
1 plus, oh, but that's not increasing by 1.
Well, it starts at 2, and then,
This would be plus 2.
yeah.
This is plus, you're saying this.
Yeah.
Plus 4. Okay, I got you there. I didn't know what you meant by increasing by 1. I get what you're saying. The intervals increase by 1. Okay, that makes sense.
I feel like an easier way to do it is just if you look, like every time each row adds one more dot on
Yeah.
each row.
You could do that.
You could kind of just draw them out if you wanted to.
You could draw them out if you wanted to. Yeah, you could. Basically, this was added on here. This is what Nico is saying is this. It was increased here, and this was increased. So the next one is going to add basically another layer of 5 if you wanted that. 1, 2, 3, 4, 5. So if you added 5 to this, that would give you 15. That works too. So either way works. They both give you the answer.
Yeah.
But then it says the 6th figure.
Oh, that was the 5th. So the 6th one would be adding 6 to that. So 21. So this would be 15 plus 6 equals 21. So you could do that. Okay. Do we want to talk about 13? How many hands? 1, 2, 3. Okay. 13 says a theater has 3,500 seats. Tickets went on sale this morning for an upcoming concert. 437 were sold in the first 30 minutes. If it continue to sell at this rate, how long will it take? Okay, so let's erase this. The first thing you know is that there's a rate. Okay, and in this rate, it's 437 tickets. 30 minutes, right? Now, the answers are all in hours. So the easiest thing to do is to figure out in hours because this is not friendly with 30 minutes. So in 1 hour, how many would they sell here? 874 tickets, okay, in 1 hour, okay? So they're trying to figure out how long will it take to sell 3,500 seats. 3,500 is equal to 874 tickets for 1 hour times X hours. Does everyone see how we did this here? Because you're basically, this is kind of the distance, the rate, the time, if you think about this. Distance is rate times time. That's kind of the same thing right there, right? The rest of it you could do and figure out how much X is, just divide by 874 and you'll find out the time in this one, okay? Any questions on that? Good? All right, let's keep moving. Number 14, I know this one, people were like, I don't have a ruler. This one, you'll have a ruler on the test day, but this one, you could have estimated this one here. What was our answer here on this one, Brian? F is your best one. This one, you could kind of see that the couch is about sort of, looks like 2 inches. So if you had that, multiplied it out, you would have gotten 8 feet on that one. All right, let's move on from there. 15, 16, 17. Wow, a lot of hands on 17. This one here, this one was tricky. And you kind of have to play with the prices that they give you to figure this out. Because this is a person named, well, correct Chinese pronunciation would be Ni Ling here. And I'm not even using the right tones on that. But I'm sure a lot of people read this as My Ling. But would be, I'm not sure what her tones would be for this name. But if she bought 4 pies, okay, and they cost $49.50 in all, the answer was 0 Neapolitans. And the reason is because if she bought the other pies here, I think if you did the math on this one, the small Neapolitans would not have fit in there. This was 45. And, oh, sorry, not 45. It's 49.50. You'd have to find a combination of the pies to figure out which one works here. If you look at it, the Neapolitan large, 11.50. If she bought 3 of those, I think that's what I ended up doing. 11.50 times 3. I think that's what I did. Was it 3 of those or 2 of those? I think. And then you added 1 large Sicilian, so that was 15. I remember doing this one. So this one became 49 and 50. That's how you would do it. So 3 of the large Neapolitan, 1 large Sicilian. Because if you try to fit that 850 in there, it wouldn't have worked. So this problem is actually trying to figure out which combination of pizzas added up to 49.50. That's all they were doing on that. Okay, so let's go to the next one. 18. 1 hand for 18. 19. You want 18? Oh, okay. Why don't you raise your hand? Too cool to raise your hand? Is that what it is? Okay. Speak or forever hold your silence. Okay. So let's talk about 18 for a second. 18 says Kate has 6 more dimes than she has nickels. So this means C is equal to 6 plus N. Okay. So this is just talking about the actual coins. She has a total of $3.60. So that means if you have this, this equation, I don't know if it's really going to help, but this is going to say 6D plus N equals, what's the amount again? $3.60. This is probably not going to help you here. This is number of dimes. This is, oh, sorry. I'm going to make a 1 here. Number of nickels. Okay, the reason I erased that other one because it actually doesn't help you that much. This means 6 dimes, 1 nickel. That's a ratio there. It's a ratio of 6 to 1 there. And we know that dimes are valued at 10 cents and nickels are 5 cents. The problem here might be that, now I'm saying ratio, it might not actually be 6 dimes. Because if you said 6 times 10 cents, that's only 60 cents. So it needs to be multiples of 6 multiples of 1. Fine?
Well, isn't it 6 plus D? Because there's 6 more dimes.
6 more dimes. 6 more dimes than nickels. But N doesn't equal 6 plus D. Right? It's not nickels that are more. She has 6 more dimes than nickels. So this would be, let me see if this helps. 6 plus N equals D. 6 more dimes than nickels. Right? So actually, I'm trying to see if this works. I don't know if that works. Hold on. The total, you know what? This is not going to work. I can tell. That doesn't work. Let's try this again. This is dealing with, we don't know the actual number of dimes, we don't know the actual number of nickels, but it equals $3.60 here. Let's see. The total is, how many coins does she have in all? Let's see what we can do here. 6 more dimes than nickels. Dimes. Well, this has to have a value, 0.1, and this has to be 0.05. So what you could do here is just do substitution. I had to go back and forth on this. If you do substitution, put this D in here, this will be 0.1 times 6 plus n plus 0.05 times n equals 60. Distribute this out, so this will be 0.6 plus 0.1 n plus 0.05 n equals 60. Add it up, this is going to be 0.15 n equals 60. Make it 59. This is terrible. 59.4. That doesn't look divisible at all. That looks.
360.
It is divisible.
360.
Oh shoot! That looked terrible. I was like, that doesn't look very good. $3 and I was like, that looks terrible. 360. 360. Subtract from there. That makes it 3. That makes it divisible. I was like, that looks terrible. So divide that. So you're going to move this over 2. Move this over 2. This is going to be 20. 20 nickels. So if you have 20 nickels and you know that she has exactly 6 more, then dimes is equal to 26. Total number of coins is what they're asking about. So it should be 46. So you add these two together, 46. I just messed up on transferring the numbers there. I was like, that doesn't look good, but it did work out. So my first guess on that formula, 6 plus n equals d, actually did work on that one. Okay. How many guys did I lose on the substitution? How many guys have not learned substitution? It's a little bit new, right? Substitution. Yeah. Well, let me just take it back a step here because this one took a little bit of translation. This problem was hard because you had to translate first. The number of nickels is smaller than the number of dimes. Dimes is equal to 6 plus n. That means the number of coins that are dimes is 6 plus n. Then you had to substitute it in here. So D becomes 6 plus n. So for the rest of it, it became this. We distributed the 10 cents in there, so you got 60 cents and you got 0.1 n. And you already have 0.05 n. I kind of messed up on the writing there, but we fixed it. So this becomes 0.05 n and 0.6. I'm sorry, and 0.1. That means 0.15 n. This 0.6 is subtracted, so 360 became 3. Okay? Divided this, it became 20 nickels. And so if it was 20 nickels, we take that back into this equation. 20 plus 6 equals 26 dimes. Total number of coins, 46. Does that make more sense? This is what I'm going to tell you because I see you staring into space or just scribbling. Write everything down. Okay? You might think, why should I write it down if I don't understand it? I will tell you a story. When I was in high school, I remember in pre-calculus class, it was a little bit new to me, and I had this one teacher, Father Hudson, and he's a really good teacher, actually. He was very clear. He wrote all the steps down. There were times when I was in that class, I didn't know what the heck he was talking about. I just wrote everything down. Write it down. You know why? Because I'm about to erase this. And once I erase it, you're not going to even understand it. And you're just going to go, well, it's over, so I don't care. But what I'm really trying to teach all of you guys here is methods. Because I can't promise you that you'll see this exact problem again, but you'll see other problems that require you to translate from words into equations. That's the first thing this did. And secondly, they'll ask you to combine 2 equations, which is what we did. This equation was combined with this equation. So translation is really, really important. combination of equations. Yes, Summer.
I just have a quick question about how did you get from 3.60 to 3.00?
Subtracted 0.6 and 0.6. So that 0.6 was subtracted. Yes.
Wait, so did you do, when you said you distributed 0.10 into 6 plus n?
Right there. This went into both of these. That's what happened. And then this was subtracted. This is what Summer was asking about. So that's why this became 3. Okay. When I did the division here, I knew this is 15 cents. This is $3. I moved the decimals out, and that's why it's 20 on that one. Okay. So what I'm trying to tell you, because I see this day in, day out, I teach well over 200 students per year. And a lot of them, they just kind of go, well, if I didn't get it, then I'm not going to write it. I'm going to tell you guys, as you get further and further into math, the only thing that's going to get you there is if you write stuff down. I know a lot of schools now, they have all the lessons on an iPad or on a website, but what that causes is students stop writing things down. They're kind of like, well, it's there, swipe to the next page, cool. The problem with that is when you don't write something down, it's harder to remember. There are psychologists who've actually done studies where if you only hear something and don't see anything, you might remember less than 10% of it. If you hear and you see, it goes up to about 30%. If you hear, you see, and you write it down, it's closer to 50%. And you guys are probably wondering, wow, that's still pretty low, right? So what gets it above 50%? Repetition. Repeating, doing it again and again and again. That's what, because I'm going to say this, and I hate to say it to everybody, but we probably don't have photographic memory. I've only had one student who had photographic memory. And if you read this problem, it says Kate has 6 more dimes than she has. If she read that once, overall, she could quote it to you 15 minutes later. And you'd be like, what? I don't even remember who had dimes or nickels or what. Okay. The only other person I knew who had photographic memory besides that student was when I was at Harvard. I had this classmate. I said, hey, Dennis, did you read this? He goes, yeah. I said, you didn't write anything. He goes, I don't need to. That guy had photographic memory. He could read it once, never had to look at it again. So.
Wait, when were you at Harvard?
A while back. Yeah. Okay. I don't think you would know people back then, though. But that's okay.
My dad.
Okay. So let's continue here. Do we want to talk about number 19 here? 20? 20? More hands? Just 2. Okay. Some people are like, no, I'm too cool to raise my hand. So let's talk about 20 for a second. This one says, on a recent exam, Roberto scored 90, Mark 82, Jacqueline 85, Mariko 84, and Leah 98. Who scored the closest to the mean? You're going to have to add these up and divide by the number of people. This is 1, 2, 3, 4, 5 people. And then you're going to just you have to find the mean in order to do this. And then you're just going to compare scores on this one. Does anybody need me to do that? You guys know how to do the mean now, right? Okay. Let's talk about 21 here. 21, 2 hands, 3. Okay. This one says integers make the inequality true. So let me erase what we have here. So let's look at this. This one says x is equal to or greater than -5, but it is less than 5. Because it's equal to, you can start with -5. You could literally count this on your fingers. -5, -3, -2, -1, 0, 1, 2, 3, 4. So that's 10. Okay, so that would be our answer there. 22, 23, 24, 25. 25? Hands for 25. Let's talk about this. When you have a cube, edges are the lines where 2 of the sides meet. So you could have your top and your side meeting at an edge, right? Just don't double count. So if I was to draw this, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's how I would do that. Just draw it out. Those are 12 edges. Did you see how I did that? I just drew it out. It's a visual exercise. Did anybody do it differently? Let's just start over again. This is just a visual exercise. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's a cue. How about number 26? Couple hands there. Okay. Anybody else? 2? I may skip it. Probability that it lands in the region marked 2. The issue here is this. This is what I'm going to say. This is a little bit of a visual exercise for this one, but I'm going to tell you that sector for A, that slice of the pie that says 2, that's probably about 1/4 of the entire, well, I'd say it's 1/8 of the entire thing, because if you look at just the half of the circle, 2, 1, and 5, 1 plus 2 is equal to 5 in that one, so that's 1/4. But then if it's the whole circle, it's 1/8. That's what I would say for that. Do we want to talk about 27, 28? One hand. 29? How many hands for 29 here? 4 hands. Okay. It says, what can you conclude about the mean time for all 10 runners here? Let's look at this. They give you the top 3 finishers here. The top 3 finishers are Ariel, Dana, and Kim. Okay. Then there are 7 other runners here who obviously were slower than them. Okay. So they had to be slower than 14.6 seconds, right? So let me just, I'm just gonna make it very visual here. 1, 2, 3. 14.6 seconds for the slowest of the top 3. There's 10 runners here, right? If these 3 are the fastest ones, the times are going to get longer than 14.6. This has to be greater than 14.6. Pretty much from 4 all the way to 10, they're all greater than 14.6, right? So I'm going to tell you that the average is going to be greater than 14.6. Okay? Because even if you just, I mean, we don't know who 5, 6, 7, 8, and 9 are, but we know that their numbers are greater than 4. This is all greater than 14.6. So even if you just did a median here, just between the 5th and the 6th, it's going to be greater than 14.6. And if you, I mean, you couldn't really calculate this accurately because we don't know the actual speeds of runners 4 through 10, but they have to be greater than 14.6. So answer has to be that. Yes, Summer?
For the answer, you put the mean is greater than 12.9 seconds.
Oh, shoot. Well, I mean, it has to be more than the other runners. The mean has to be greater than, well, I mean, if all the other runners were, it has to be greater than the average of those 3. 10 runners. We don't know the actual numbers for the others, but I mean, worst case scenario is runners 7 through 10 all finished right after this person who was in 3rd place, who's Kim, right? 14.6. What if they all finish 14.7? You could do, let's do worst case scenario for a second. Let's just look at this for a second. You have 14.7 times 7 And then you have the other three. I'm just going to do this for the sake of convenience, just because it's painful to add these up. But if you have 11.8 plus 12.3 plus 14.6, this is 38.7. So 14.7 times 7 is 102. This is 102.9. Let's just add them up. Plus 38.7 divided by 10. Oh, you know what? That came out to 14.16. I was wrong on that. So it would not be 14.6. It would be C. That's the only way. Actually, I calculated worst case scenario. Worst case scenario is the runners were really tight and there wasn't somebody lagging way, way behind. And I made the all runners 7 through 10. I'm sorry, 4 through 10 coming in at 14.7. It turns out the average would have been 14.16. So out of worst case scenario, yeah, the answer was C. So that actually gives us enough evidence of that. Questions on that one? I actually had to calculate. Okay, that was kind of different. How about 30? 2 hands on 30, that's it? Just 2 hands. This is, suppose you want to draw a bar graph that makes Ariel's time look much better than the rest. Ariel is 11.8. And you're looking at these, right? This is what I'm going to say. If you're going to make her time look significantly better, she's only about 1 second faster, 1 point something faster than Kim, and not even 1 second faster than Dana. So I would use the graph that has the most notches between the numbers. But if you look at like J, it's going to make them look all similar to each other because they're too close to each other, right? If you look at let's see, which one would I go between? I mean, the 14.6 versus 12.3 versus 11. I mean, those are defined pretty well. I like F more than H. I think you can't see the differences as well. I kind of like F the most. Is that what they went with on that one? Because it has the most notches. It has notches between 14 and 15, not just between 13 and 14. It shows the differences. Whereas when your numbers get bigger, like 20, you can't really notice the differences between 11.8, 4.6. You can't see it as much. Okay. That's more visual than anything else. There's not really calculating. Are we talking about 31 here? This is about substitution. You should have inserted 4 for the A's and -2 for the B's. The rest is calculation on that one. How about 32, 33, 34? Couple hands on 34. This one is talking about output and input. And if you look at this, you should look for the trend between the numbers here. What I see here at the inputs is adding 3, adding 4, adding 5. Well, that's kind of weird there. Adding 3, adding 3, adding 4, adding 2, 3. It's kind of a strange one. Now, or if you put a 1 in there, you get a 1. 4, you get a 7. So that's 3. The difference is 3. The difference is 7. The difference goes to 13 and 25. It's kind of like looking for a trend. What is the sum of the two missing ones? Well, it's going to be between 15 and 25. So let's see how we would do this one. 8, 6. This is kind of strange here. What I would do is you could treat these as an X and Y and do a slope on this. Yes, Deborah?
I just wanted to say multiply by 2 and then minus 1.
You saw a trend of multiplying by 2 and subtracting by 1. You could do that for the y values, right? Multiplied by 2 minus 1, 30, 20. Well, that's weird. How would you get that? Multiplying by 2.
4 times 2 is 8 minus 1, so
Oh, I see what you're saying.
that's 4.
And you're saying, okay, I get what you're saying. Multiply it and then subtract 1. 16 minus 1, 20. So that would be a 19 for the y value of the output. And then for the next one after that, that would have been 13, 26. So 32. That would have been 16 plus 19 then on this one. That would give you 35 on that. That's a good formula there. You kind of had to look for a trend in how the numbers were increasing and affecting each other. The way that she had it was basically 2x minus 1 equals y. That's what she did, treating them as 2x minus 1. You could have done that. Okay. Let's go with number 35. How many hands are for 35? Okay, that's a lot of people there. Let's talk about this one. This says time it takes Yolanda to drive her grandfather's house. Something like that. The minute hand of the clock completes R revolutions. During that same time, how many revolutions does the second hand of the clock? Well, we know this. The second hand for each minute, so it goes around, the second hand, how many times? The second hand goes around once for each minute, okay? So let's see how we would do this one here. How many times? So if minutes is equal to R, because for each, well, shoot, that doesn't make sense. But minute, hour, 1 hour equals R minutes. Is that a good way to say it? No, that doesn't work well. Let me see how we do this here. Let's make this is comparisons here. Let's see how we do this. So it says, during the time it takes Yolanda to drive to her grandfather's house, the minute hand completes R. So R is equal to number of revolutions in that time. So 1 revolution in minutes is 1 hour. So I'm trying to go backwards to seconds. So in seconds, 60 seconds equals 1 minute, okay? And 60 minutes equals 1 revolution. Let's see how I do this. So R revolutions. One revolution equals. So this is how I would look at it. We know 1 revolution of the minute hand equals the minute hand of the clock completes R. So if this was 60 minutes is 1 revolution. We don't know how many R is. R could be any number. So R revolutions times 1 rev equals 60 minutes. 1 minute equals 60 seconds. So when I do this, 60 times R, let me see what I would do here. 60 revolutions. I don't know if I put too many in here. But it should be 60 times R. If R is 1 revolution, I don't know if I need to do it that way. How many revolutions? Let me see what this is real quick. Just a second on this. This is number 35. That's 60. They went with 60R on this one. I'm thinking I put too many things on here for this, but it should be the number of seconds. R revolutions. I know it's 60R, but I gotta figure out how I did this. They don't care about hours on this. One revolution equals, let's try this, 60 minutes. You want to try that, Deborah?
Well, 1 minute equals an R.
1 minute.
1 minute equals R.
R.
60 minutes in an hour.
I was making it an hour. That was my problem.
So that means there's 60 times R.
60 times R. I think that's what I did wrong. It's 1 minute equals that.
I didn't get it because I thought that the second hand was like the second, like the 2 MD hand, as
Right.
opposed to the unit of time.
I know, it's kind of confusing. 1 minute of the hand completes the minute hand completes R revolutions in that time. R revolutions. Minute hand revolutions. How many revolutions does a second hand? That's why I was thinking 60 times 60 times R, but they're just going with 60R. I would have based it on 1 hour and 60, but it's a little confusing there on that. If you just used if you said 1R for the time, the minute hand made 1 revolution. That's 1 revolution of the minute hand. So then you'd multiply that by 60. That makes more sense now. If it was 1 revolution, that means the minute hand went around once. You just multiply that minutes times 60. So 60 times R. Because you would multiply, if it was 1R, then you'd multiply it by 60 to get the second hand. Okay. That was a little hard. Let's go to 36 then. 36, 37, 38. Let's go to 38. 38, nobody. 39. A couple of hands on 39. How many registered voters are there in this state? Let's double check this real quick. Let's see here. So we have less than half of all registered voters. Typically, there's 68%. Turnout was the highest there were 780,000 voting. Okay. Women outnumbered men 6-1. Let's double check this here. Registered voters. How many? Well, let's double check this. 68% of, this is what I would do. There's 780,000 people who actually showed up. This is who actually voted. This was 68% of registered. That's what I would do there. So 68% of registered voters, because I think the answer here was, it has to be more than the 780,000. But just to make it quick here, if you said 780 divided by 0.68, we get the number there. And if you did the math here, I'm just going to save you time. This gives you registered voters, divide by 0.68, divide by 0.68, registered equals 1,147,058. So that's the closest number to that was A, which is 1.1 million. If you did all the math here, I just did that really quickly for you guys. You'd get 1,147,058 voters, which is closest to A on the answer on that one. Okay. Do you guys want to take a quick break? Do that, and then we'll resume in a second. We still have only a few more problems here. All right, let's do that.